So we did a lot, but there's far more, of course, that we didn't do. We did a lot of model-free, called model-free methods, which is you don't make any assumptions about this joint distribution of the data. But there's a whole wealth of interesting methods where you do encode your prior knowledge about this about this distribution. So these are more probabilistic approaches. So you might look into topics like graphical models or probabilistic learning and inference. Probabilistic programming is pretty cool. Books, David Barber's on our website. Kevin Murphy's a classic book. He has a lot of, it's not classic, it's kind of an advanced PhD level survey book. Neural networks, you could, of course, go much further in neural networks. So if you want to do like natural language processing, Yoav Goldberg has a really nice book. There's the deep learning book that was published about a year or two ago by Goodfellow, Bengio, and Corville. Stanford CS231N is a great course on computer vision with neural networks, and they teach neural networks from the beginning with backprop and that if you want another pass through that type of material. They go into much more depth. I mean, the whole course is on it, so they go into much more depth on issues that can happen with backprop, like exploding gradients and decaying gradients, these sorts of things. It's a nice course. Lectures are on YouTube. What else? You can also just search out other courses kind of at this level, other things called like machine learning or fundamentals of machine learning, because there's so many topics one can choose from that there's a lot of, there'll be overlap, but there's different perspectives that get taught in each. So like some hit a much more Bayesian perspective and probabilistic perspective early on. We left that till the end. No way is right or wrong. Some other topics we did not cover but are kind of at this level. More on the probabilistic side of things, these latent Dirichlet allocation or topic models, maybe you've heard of, kind of for automatically clustering documents in ways that seem intuitive. Sequence models, so could use this for time series, but they're mostly used for more discrete state type things, so hidden Markov models and maximum entry Markov models and conditional random fields. These are used heavily, well, at least the last two, or the last one, are used heavily in natural language processing. You can go much deeper on Bayesian methods. Collaborative filtering and recommendations, that's something we didn't have time for, kind of matrix factorization approaches and these sorts of things. We did get to talk about ranking a bit in the lab section, if you were there, in relation to multi-class. We talked about a kind of a way we could apply this to ranking. Bandit problems. This is interesting. This is kind of this notion of exploration exploitation. So kind of the classic example in recent years is computational online advertising. So you have all these ads that you just serve to users. And initially, you don't have much data on any ad. It's just someone just gave it to you. And you can try different ads with different types of people and see what people like and what they don't like. And because you want people to click on the ads, that's how you get your money. So there's a certain amount of exploration one needs to do to try out certain matches between people and ads. But at a certain point, you might want to just focus on serving the ads that you think will have the highest payoff and not waste time with kind of, exploring new possible connections between person type and ad type. So a way to trade off between that is kind of a major topic of bandit problems and perhaps more generally reinforcement learning. Finally, Gaussian processes. If you enjoyed the Bayesian linear regression stuff, I think it's fun. The natural progression from there is it's called Gaussian Processes. And there's a great book called, I think it's called Gaussian Processes for Machine Learning or something. You'll see it's free online. And kind of chapter 2 of the book is kind of what we did in Bayesian linear regression. And then chapter 3 gets into Gaussian processes, which it nicely combines kernels, which we talked about, kernel methods, which become covariance functions in a Gaussian process with Bayesian methods. So it's a nice way to do nonlinear regression. It's used for things like spatial statistics. Thanks a lot, guys. It was a lot of fun. See you Thursday.